Okay, we are going to talk about polynomials. You guys know what polynomial is? Okay, very good. Polynomial is something like this. For example, if you have f of x, and then all the polynomials are going to look something like this, where you have a coefficient, let's say a, and let's say it's for the nth term, so we put an n there, and then you always have x, and then that's always to some kind of power. Let's just call it n's power. So then basically we're saying a n is matching up to the x to the nth term. And then the next term is going to be probably just, not probably, it's going to be n minus 1 term, meaning like that's the next term. And then the power is going to be 1 less. And so on until we get to the second to the last term. Second to the last term, we're going to call this a1, and then that is x to the first power. And then the last one is going to be just a constant with no x. So that's a typical polynomial. So in this case, a is what we call the coefficient. Coefficient is always the number in front of x. And we say that number is not equal to 0 because if it's equal to 0, it's going to be no term. There's no term because it's 0. N is going to be the exponent. And that exponent is not negative, non-negative. Because if it is negative, it's going to cause it to go in the denominator. When it does go into the denominator, it's not a polynomial function. It's going to be a rational function. Degree. Let's kind of review. So for example, let's look at this polynomial here. 3x to the 5th minus 4x plus 5. What is the degree of this polynomial? 5. Yeah, the degree is 5. Why is it 5? Yes. What exponent though? The what? No. What? So, okay, degree is 5, but why is it 5? Why is it not 6? Why is it not 1? The highest number. The highest exponent. It's right there. Can you not see it? Okay, it's the highest exponent. Then what is the leading coefficient? For that one, 3. Yes, the leading coefficient is 3 in this case. And how do you know that's the leading coefficient? It's in the front of what? Yes, in front of the highest degree. So it's the coefficient in front of the highest degree. All right, let's have you guys try this. A, B, C, D. You have to pick the one that is or the ones that are polynomial functions. All right, let's vote. How many people think A is a polynomial? Okay, definitely. How about B? Okay, definitely not. C? Okay, D? Okay, C is not a polynomial because inside, yes, that part is a polynomial, but that square root basically makes it not a polynomial. Square root, remember, is to the 1/2 power, and if you do make this a 1/2 power, you cannot distribute that 1/2 power to anything. Even if it does, it won't not work. I think all the polynomials, should have integer, positive integer exponents. All right, only A and D. Let's look at the typical polynomial function. First one is called the 0 function. That's a special case where f of x is equal to 0. Remember we said that the coefficient cannot be 0. So this is a special case where it is 0. So we just know that as a special case and we don't really talk about that. The first real function is constant function where f of x is equal to just a number. So what is the degree of this function? 1? No. Degree, remember, is the exponent in front of x. Yes, but everybody else is like thinking. Okay, so how are we going to get an x when there's no x? Are you thinking or just like waiting for me to give you an answer? Okay. So it's going to be x to the 0, right? That's the only way you can have an x in there but not see an x. X to the 0 is going to be 1, so then that's going to be a times 1. Okay, so the degree is 0. Ax plus b is a linear function. What is the degree? Everyone should know. Okay, people here. 1. Okay. Quadratic, what is the degree? Everybody here.
2.
Very good, 2. All right, now let's look at linear functions. So we're going to just talk about linear function really quickly. Linear functions has a degree of 1, half a degree of 1. It is a line, a straight line. This question says, find an equation for the linear function f such that f of negative 1 is 2 and f of 3 is negative 2. What does it mean when f of negative 1 is 2? Function of negative 1 as an x equals 2. Can you write it as an ordered pair? Negative 1 what? Yes, negative 1, 2. Remember that inside the function is an x, outside that's a y. So negative 1, 2. And this is going to be 3, negative 2. So can you write a straight line with these 2 points? Yes, of course. Okay, go ahead and do that. Let me know when you're done, and then you can go on to the next one. Okay, this first one is y equals minus x plus 1. The second one, if you try that, is y equals 4/3 x plus 4/3. All right, moving on. So when we do slope in algebra course, that is y2 minus y1 over x2 minus x1. That is the change in y over change in x. So when we say change in y, we put a triangle that's a delta, meaning change. So change in y over change in x. Change in y over change in x. So that delta means change, okay? This is actually called the rate of change. So you'll do that a lot if you take calculus next year. Rate of change. Rate of change is how fast are you changing in the y over how fast you're changing in the x. So it's the rate of how fast things are changing. If the function is linear, then the rate of change must be constant. And that makes sense. Because if it is linear, then how fast you're changing from one point to the other obviously has to be exactly the same, because that's the slope. If you're non-linear, like you have a parabola or some kind of curve, then going from one place to the next, the change is going to be not constant. Okay? So, quick review on linear. Next, quadratic. Quadratic is a degree of 2. That is a parabola. There are 2 general forms of quadratic function. The first one is called the standard form. Do you guys remember the standard form? Ax squared plus bx plus c. And then the next one is called the vertex form. Obviously, it has a vertex in there. Do you remember? It also starts with A. Good. All right, which part is the vertex? HK. Good, HK. Now, because it's a parabola, it's going to have an axis of symmetry where if you draw that straight line down in the middle, it's going to look exactly the same on both sides. Because it's a vertical line, that's an x equals 2 equation. And because it has to go through the vertex, it has to be x equals h. What does x-intercept mean? X-intercept is when what happens? Okay, yes, when y is equal to 0. Okay, so we are going to now change from standard form into vertex form. There are two ways to do it, if you recall from last year. The first way was we gotta find h and k, right? So then we said h is equal to negative b over 2a, and then k is basically a function of h. That was the first way. Do you guys still kind of remember this? Yes, maybe. So it's changing from standard form into vertex form. The second way is complete the square. We are going to complete the square. Okay, if you don't remember, again, chapter P, we did a lot of complete the square back then. F of x is equal to 3x squared plus 12x plus 11. All right, we are going to complete the square. Do you remember what the first step is? Remove c. Yes, usually, yes, but that's when we're solving for x-intercept. This is changing into another form, so we actually don't want to move the 11. If we move the 11, we kind of throw it into the f of x side, and it gets really crazy. The first thing we're going to do is put parentheses around. So group the x's together. Next, we're going to do something. Before magic number.
Oh, take 3 out.
Yes, take 3 out. Please do not take 3x out. Just the leading coefficient. We take out whatever is leading the whole thing. Okay, this is going to be plus 4x plus magic number. Plus 11. Now what? I added a magic number here. I cannot change on the other side of my equation, so what do I have to do here on that side? Subtract. Now, how many magic numbers do I have to subtract out this time? 3 of them, because there's a 3 in the front, right? So I have to subtract 3 of them out. Next, what is my magic number? 4. Can you guys see that? Okay, so it's going to be b over 2 squared. That's the magic number. B, you have to use this 4. Please don't go back to the original function and look at 12. No. After you change it, then look at the magic number. So that's going to be a 4. The last thing you're going to do is factor simplify. 3 times x plus 2 squared. That's going to be minus 1. This is an easy one to complete the square. Where is the vertex? Yeah, negative 2, negative 1. Okay, axis of symmetry is x equals h, so what is that? X equals what number? Yes, negative 2. So this is the changing from standard form into vertex form using complete the square. Now, again, you can use h and k the other way, but I think this one you may be able to remember it a little better, I think. Next, you're going to see a graph, and you have to write an equation. So this is the graph they give you. It looks like a parabola. It is a parabola. You're going to write a quadratic equation. It doesn't say what form it wants, but since one of them is a vertex, we're going to use the vertex form. That would be the fastest way. Okay, what are the 2 letters for vertex? HK, good. And a random point that is not the vertex on the parabola is just xy. Okay, so now let's take a look. Since we're writing in vertex form, we're going to just start with the vertex form. So y equals a times x minus h squared plus k. Now, let's look at this vertex form. In this vertex form, we have 5 variables, y, a, x, h, k. If you look to the right where the 2 points are, you have xy, and hk. If you compare, basically the only thing that we don't have is a. So all we have to do is plug it in and then solve for a to figure out what the stretch of this parabola is, and then we're done. Does that kind of make sense? Okay, so that's what you're going to do right now. You're going to find a so that you can write the vertex form. Okay, when you have the vertex form, please let me know.